Welcome, everyone, to this seminar titled Introduction to Automation in Horticulture. My name is Hussam Haroun, and I'm the Director of Automation Group at Vineland Research Innovation Center. Here's a look at the topics we'll be covering. We'll start by introducing the high level opportunities that exist for making use of automation in horticulture. Then we'll present the major categories or aspects of the automation. After that, we'll talk about the common challenges encountered when developing and deploying automation solutions. And finally, we will present a brief overview of automation research being undertaken at Vineland. So, what are the opportunities we see now and in the future? When we talk about the kind of opportunities where automation can improve the industry, we're really highlighting the high level benefits such as reducing labor costs, improving quality, increasing yield, and boosting efficiency. Now, of course, there are a lot of things we can do with automation that are interesting and push the limits of technology for the sake of research. But at Vineland, we are always focused on making a real impact and seeing growers implement automation solutions as new products. That means that we see automation through the lens of return on investment. A new technology is only really worthwhile if the benefit outweighs the cost within a reasonable timeline. So, what kind of technologies do we typically see used in automation solutions? Automation is a major buzzword uh, in the way we think about the future of agriculture and horticulture, but it's not actually new. There is a wide range of automation technology that is already available for use in horticulture industry and has been adopted to some degree in the majority of commercial endeavors. Here are some examples. A lot of the existing automation can be found in inventory management, materials handling, plenty of solutions for automating irrigation, usually scheduled valve control, and finally, in automated weather monitoring systems are essentially ubiquitous. Outdoors in orchards, for example, you can find an automated weather monitoring and data agglomeration systems. A more recent focus in automation across all industries is the use of artificial intelligence and data science. As our world becomes more interconnected and we start using more sensors and accumulating more data, we're seeing enormous jump in the capabilities of AI to learn patterns in data and apply that to monitor and track various features of crops, predict things like yield, pest management, and optimize inventory management. But using AI has some subtle complexities that can sometimes be overlooked. For example, there are a lot of interesting implications for how AI and data impacts the horticulture industry. Growers are able to afford their decision-making needs to a computer, greatly increase the efficiency of their business, and supplement their own knowledge and expertise with the power of machine learning. But who owns that data and how does it get used? How reliable is artificial intelligence and how does a grower come to trust a computer's decisions? When your livelihood is on the line, it's important for researchers like us to get it right and mitigate risks well in advance. Growers across different crop types identify pest management as an emerging challenge, facing both increasing pest pressures and limitations on fungicides. Some notable technologies for pest management exist in the form of unmanned aerial vehicles such as drone technology and the potential for them to both scout and apply pest management products. Some growers express concerns in regards to their likely adoption of such technology, pointing to the size of operations in Ontario and questioning its economic viability. An example is the DJI Agras MG-1P drone sprayer. Fly up and over the fields without soil compaction or crop damage. Spray locations when you need to, precisely where you need to. Another form of technology used for disease detection also includes cameras. Cameras are inexpensive, and nowadays we're mostly all carrying them around everywhere we go in our pockets. There's a ton of things we can see with our eyes that we're trying to teach computers to see as well. And many companies are pushing the limits of what we can do with deep learning. You can certainly find examples of computer vision being used to detect and track growth, assess ripeness, detect disease or pests, and of course, look at quality of products as they're being sorted and packed. So this leads us to the last category we'll talk about, robotics. You can already find robotics systems being used for packing, which is relatively easy since the product can be sorted and presented to the robot in a more accessible fashion. Taking the robot into the field, the nursery is a lot more difficult as we now need the system to carefully interact with the plant for applications like harvesting, weeding, or pruning, or material handling. Applications like that are in many ways a final frontier for automation in horticulture. There are many challenges, but the benefits will be enormous. I would add that robotics can be particularly challenging when it comes to adoption by growers. It can be difficult enough to trust a new employee, but even more difficult to build that trust with a machine that isn't intended to be supervised or controlled. Why don't we go through the next section and understand the challenges that exist in automation? Okay, so we'll look at some of the primary challenges we face when developing and implementing automation solution in horticulture. The first thing we'll talk about is the fact that in this industry you're dealing with highly dynamic unstructured environments. Say in comparison to something like a warehouse, plants change as they grow, lighting changes over the course of the day and as the season progresses, and it's possible you may or may not have humans equipped around. So it's therefore difficult to predict the environment and keep track of features. A, a piece of fruit is almost guaranteed to have moved since yesterday, and a plant is guaranteed to be continuously changing. This is where humans have such a great advantage over computers. Our brains are naturally attuned to seeing patterns through noise handling these dynamic environments. For automation, we're seeing the use of machine learning as fundamental to how we tackle this challenge. By adding what is called plasticity in the learning framework, we don't need to rely on the environment being static. Well, another major challenge is how we interact with the plants using robotics. In many applications for robotics, the objects we want to interact with are rigid and easily defined as being fragile or sturdy. We know very well that we can bump into what we need to carefully avoid. Plants are a lot trickier in an orchard. We know we don't want to damage fruit, but of course that's the thing we want to grab onto when harvesting. We don't want to damage leaves, but we can often easily bump into them and not even worry about moving them out of the way. And some branches or vines are in the middle ground where we can probably knock into them to some degree, but we can't push them too far without causing damage. Handling this challenge is undertaken by using what we call compliance, whereby the robot expects to be able to move with some measure of freedom, but can use different settings for handling resistance when it bumps into different types of objects. Interacting with plants. Some plants are more sensitive than others. What I would say that the aspect we're always keenly aware of is how a robot might transfer disease and pests, and what other interactions with plants such as pruning or harvesting, means for the plant's health. Robots don't typically go home to take a shower and change clothes. And when they make a cut on a plant, they aren't necessarily inspecting to see if that cut's clean and straight enough. So ensuring the robot is able to perform its duties with the well-being of the plant in mind is very important. We often see growers following different practices when it comes to crop management and plant production strategies. For example, irrigation and pest management and pruning and harvesting and so on can vary based on growers' preference and experience. And although in general it can seem like those differences are subtle, for an automation system they can result in vastly different requirements and settings. That can also be true for the way growers schedule labor. If staff prune and harvest at the same time, then bringing in a robot that only harvests means extra work for the grower in terms of interacting with those systems that are operating. Now let's talk a little bit about automation at Vineland. So the automation group of Vineland, who we are and what we do. At the beginning, I've introduced myself as the group's director. My main role is to play in building and fostering relationships with partners, securing new projects, and maintaining a productive workflow for our team and our projects. The team we have is multidisciplinary, covering a variety of expertise in robotics, computer vision, AI software, mechanical, and electrical systems. Within that team, we also have a range of experience and knowledge, including technicians, engineers, scientists. We also work closely with experts in other departments, including consumer insights, plant production, and of course, our staff. We also look at collaborating with external stakeholders and experts from universities like University of Guelph, nursery staff, and experts such as staff from Landscape Ontario. Now let's talk a little bit about the goals of the program. So the specific objective of the automation group is to develop technologies that reduce labor costs and improve productivity. We measure our success based on real life impact we make on the horticulture industry, not simply in interesting research advancements we contribute. That means that the automation solution we develop need to perform well, but with reasonable return on investment for growers. So compared to other companies and research groups in the area of horticulture automation, Vineland has a major advantage that we can design something at our desk, prototype it in our workshop, test in our greenhouse or orchards, and then take the lessons we learn and go to reiterate our design. This lets us reduce the risk we talked about earlier in terms of bringing new technologies to commercial operations for testing. Now, automation cluster, we have a project called the Smart Irrigation Platform. It focuses on the use of artificial intelligence to make irrigation decisions for potted plants in greenhouses, including flowers and herbs. This concept could be applied for nurseries as well. Various sources of data, including what's already available from the climate computers or weather, are combined with historical decisions made by growers themselves to map out and correlate their relationship into irrigation patterns so the future decisions can be made by the computer. We've seen this system lead to significant improvements in quality since it removes some of the subjectivity of decision making process and also reduces labor associated with scouting. At the moment, we're in the process of commercializing the smart irrigation technology with our partner Let'sGrow.com, who will be integrating it into their online platform and delivering it to customers starting this year. So, what's the outlook for the future? We know that automation in all industries is gaining more traction as the capabilities of these technologies grow and costs go down. The horticulture industry is one which we're at a significant milestone in terms of opportunity and technology readiness. So it's only a matter of time before the technologies we've talked about today are in every nursery, greenhouse, or orchard. It's also becoming more and more important to address the increasing costs and decreasing availability of labor. So we see automation as fundamentally important for this industry. At Vineland, the automation group continues to grow in expertise and capability and are always keen to take on new challenges and open our doors to new opportunities for interesting projects and fruitful partnerships. Thanks everyone who's watched our presentation, and we look forward to the chance to participate in person sometime in the future.